Hey everyone, today we're at Steam Shop Days, not in his steam machine shop but out in the automotive area. Because what we're going to do is partly a little experiment for me with the bikes. Instead of putting new valve guides into this Enfield engine, Dave's going to sleeve them the way they do with a lot of engines now. So what I'm going to do is zoom you in and Dave will talk us through the equipment and the process.
What this is what they call a bronze guide liner. It's some type of phosphor bronze, incredibly tough, spiraled, sort of like a real thin wall bushing. You normally put in a cast iron cylinder head that doesn't have any replaceable guides, or I put it in, install them inside of regular cast iron removable guides. But I've never tried to put one in a bronze guide before, so we're going to try it, see how it goes. The size is 11/32, which is a standard size for like Chevys and Fords, so that's no problem. So to do it, you got a solid carbide special reamer here that pilots on what's left of the old guide and cuts it 30 thousandths oversize. And the whole trick is to get them straight. So you have this little guide with the angle of the valve seat on it that actually locates it center-wise, and then you use what's left of the guide to locate the bottom end. And I normally set them up in a special machine over here that holds those guide bushings tight, but I got to do it by hand here on this. Okay, so we're set up to go. All right. You can see we got a nice clean honed reamed hole, 30 thousandths oversized. So give it a little WD-40. And we have an installation tool here. That is the wrong size. We need 3/8 or 11/32. Okay. So these are a specialty thing for automotive use, and the ends of them are, one end of it is slightly chamfered to get started in the hole. See, it's way longer than it has to be. So you trim it with a trimming tool, which is really nothing more than a spot phaser. Now that material that this is made of is so tough and so hard that you can't ream it with a reamer. You could run a new reamer down in there and it will stick it, and you'll have to drive it out. The only way you can size them is to actually drive what is called a ball broach through the bushing, and it stretches it and wedges it to size. This is about maybe 1/1000th bigger than the hole, and this is maybe 1/2,000th bigger than that. So there's several sizes, and you just keep going until you got the clearance you want. That was one. I know that's not going to be big enough. This is number, oh, that was number 2. This is number 3. Try a test fit here. Ooh. I was a little concerned because these valves were actually 343, and usually American domestic automobile like a Chevy is 341, and that's what these bushings were sized for, but it went fine. The only thing we got to do, I'm going to hit this side with a trimmer once more, because it actually stretched it through. I don't know if you can see it, but I had trimmed that down flush, and it's now about maybe a 32nd of an inch higher, so it actually stretched it. To deburr the end, I just use a tapered reamer by hand. Still got a little catch right here, right at the very end. Ah, yes. Just about right.
Well, I got the heads back from Steam Shop Dave, because after he'd done the guides, which I've just been watching, he had to cut new valve seats so that everything is right lined up. So there it is, nicely cut new seats. You can see I think you can just about see the guides in there, so the valves fit beautifully. So the next thing is, on this head we've got some damage. So I'm going to zoom you in here, see if I can get close enough for you to see it, and I'll show you what it is and explain what we're going to do. Here's the problem. It's this plug hole. First of all, it's got the common problem in that there's virtually no threads in it. That's not a great deal. We just put a thread insert in there, but the other thing is, can you see it here? There's a chunk broken out. So that's going to have to be built up with aluminium weld and then machined. So this gives me 2 or 3 problems. Let me pull you back out again, and then I'll talk about how I'm planning to deal with them. Now, as I mentioned there, the strip thread isn't a big problem. We'll use one of these, which the first part guides it in, the second part cuts a new thread for an insert, and then you put the insert in. But what is going to cause us a little bit of a problem is building this alloy up. It's going to be a little difficult to get in
But more than that, we're going to have problems holding this, and then I'm going to have to, you know, build it up to excess, then cut the thread in it, and then we're going to have to get an end mill in to flatten that off. Now, I thought about this for a bit, and as often with a lot of jobs, particularly if you're going to do some milling, the big problem is always how you're going to hold the part. So I made this up. It's a spark plug in a piece of 3/4 round stock, and I turned it down. I did this in the lathe. What I did was broke the insulation out the spark plug so there's nothing in there, and then turned the end and made sure it was all nice and true to the thread. And then this, I turned one end down to fit inside, made a nice tight fit, made sure it was all running absolutely true with the line of the thread so that everything is concentric. I then tacked this and then put it back in the lathe and turned it and put an indicator on to make sure I'd kept everything nice and straight, and then welded it up. And the idea is this: we're going to screw this in from this side. There's just enough thread left, and what thread there is, the good thread, is down at the bottom. So it's getting this to screw in nice and straight. As you can see, it's not that easy to screw in. What I might do is drill a little hole, cross hole, and put a bar in. There we go. Now this is going to solve a couple of problems for me. One is it's going to make it easier to hold while I'm welding at an angle. I can put this in a little vise on the welding table. The other thing is, let me see if you can see this. More or less. It actually sticks up enough to act as backing for the weld. So when I put some weld in, that plug will stop it from forming inside the hole and making it difficult to get our tap in. Now, I wasn't sure whether that would work, so what I did was I got a piece of 1/4 inch plate and I drilled it and tapped it with a spark plug hole and screwed a spark plug through, and then built up a load of weld on one side, and the spark plug just screwed straight out. In fact, it even left a thread impression in it. So we can weld that. Now the other thing is, I'm going to pull you out a little bit more even. Because I took great care making sure this was on exactly the same line as the threads, if I put that in the milling vise in the V-blocks to make sure it's absolutely vertical, then I know this angled face of where the plug goes is going to be horizontal. So when the mill comes down, it's going to get it, the mill cutter, it's going to get that surface at exactly the right angle. I don't have to worry about getting an angle on it, getting a slope, you know, and it not sealing with the washer. So that will go in the vise, and then the milling cutter will be in exactly the same plane. It'll come down and cut that out nicely. So let's get things cleaned up. Start the TIG up, and the first thing we'll do is the welding. I'm just going to leave this like that. It's resting on the bar. You can see the pieces sticking out, and I'm going to weld it. I've extended the stick out for this, and I've upped the gas rate, the argon rate, to make sure I've got a good shield. And I'm going to put it in this way, I think, and that way I can get at the whole of the broken piece with the filler rod and just build it up like so. That's the plan anyway. Talking as if I knew what I was doing. Okay, so let's see if I can weld that. I won't show you that because all you're going to get is bzzz, and then it'll be done. So I'll show you it when it's done. Okay, a couple of things I forgot to mention. One is I gave it a good heat People say preheat, but I just heated it. I didn't pre anything. Anyway, God, I'm rambling again. So I heated it up first of all because this is a big block of aluminium, so it really loses the heat rapidly. And also because of that, I actually had it standing on something to insulate it from the big heat sink of the table. But of course it was earthed because it's got this screwed in and that's sitting on the table. So let me zoom you in. Whoops, in you fool. And now you can see that I've built all the weld up. And here is the acid test, as they say, of the theory. There you go. Out will come that piece. So there I haven't sort of filled in the actual plug hole. I'm just on the outside of it, which is fine for that sealing washer to go on. So the next thing is to put this in the mill. Now I've got it mounted in the mill. You can see here that it's in the V grips in the vise. So what I've done is I put a slightly smaller end mill in so that I could come down and get it touched off on the existing piece so that I know how far I want to be. So now all I've got to do is set this going and come forward and mill out the new alloy. And there it is, milled off. So the next thing we've got to do is put our new thread insert in. First thing we've got to do is thread it for the insert. So as I say, the first part of this tap is the size of the existing plug hole, so that screws in and guides it the rest of the way. So that goes in like that. Because there's not much thread there, don't forget, so make sure it goes in straight. I'm going to have to turn this round so I can get at it easily. Then see if I put you back in view over a bit. Now this thing obviously is threaded on the outside, but also just around the top it's not exactly knurled, but it has little grippy things, and there is a tool that goes in there. Unlike a helicoil with a tang on, you screw this thing in, and then when it's in you put that in and you batter it, and it opens this end out, and those little serrated bits grip in the top of the plug. So I wonder if I can screw this in with a... It's a while since I've done one of these. That goes. Screw it in like that till it's just below the level of there, like that. And we get this. And voila! One nice new plug hole with a land for the sealing washer to go on. Very good. Alright, that's that job done. Now I was going to show you once again, just for people who hadn't seen it, how to put the valves in and the valve springs, etc. But that annoying thing happened. I got the new valves out and they're completely different to the ones I took out. You can see how much bigger that is, taller, both of them. So I phoned Hitchcock's because I know I'd looked up the right model and everything, and it turns out that the engine I'm using is a 59, and Enfield decided sort of a year early that they would put what they were planning to put in the 1960 engines into the 59 engine for the ones they supplied to Brockhouse for the Indian. So these are the old type springs and these are the slightly newer ones. So bugger, yeah. So the video's long enough, I think. We'll stop there and let you go off and do whatever it is you do, and I'll see you next time.